Hello boys and girls, welcome back to another edition of Geometry Excellence Television. Okay, let's see what we got going today. Alright, students will be able to find other ratios when given sine, cosine, and tangent, even when not given a diagram and when Pythagorean theorem is needed first. Cool! Okay, so because trig functions are the same for similar triangles, you can draw a right triangle and use the numbers in trig ratios as the side lengths. So that sounds kind of crazy, but we can figure it out. So check this out. For all the problems below, C is the right angle in triangle ABC. Okay, fine. Here's the problem. Finally. Okay, let's do it. Sine of A equals 3 over 5. Find tangent of B. Okay. So I'm going to draw a right triangle. C is the right angle. That's what they say, right? So A, B, C. C is the right angle. Okay, so sine of A is 3 out of 5. So I'm going to write SOHCAHTOA here. Okay, here's A. Sine is, well, this is the opposite, this is the adjacent, and this is the hypotenuse. Okay, so sine is 3 is the opposite, the hypotenuse is 5. So you see that? So the sine is 3 out of 5, so that would be the opposite, which is 3 over the hypotenuse, 5. Okay, so now, what am I looking for? I want the tangent of B. Okay, so here's B. So find the tangent of that. So here's B. Tangent is the opposite over adjacent. So the opposite is actually here for, if I'm looking at B, and the adjacent is here. So I need this side, so it's something over 3. That's what I'm thinking. Okay, so how do I get that side? I can use Pythagorean theorem like it said up here, right? So let's call this A. I don't know, it doesn't matter. So I got A squared plus 3 squared equals 5 squared. You may know this. This is a Pythagorean triple. So A squared plus 9 equals 25. Subtract 9, and you got A squared equals 16. Square root both sides, and A equals plus or minus 4, but we're just using the 4 because distance is positive. So we get 4 right there, okay. So we Pythagorean, we got 4. So tangent of B is the opposite over adjacent, so that would be 4 over 3 is the answer. So the tangent of B is 4 over 3. Got it. Okay, let's try another one. Alright, if tangent of B is 12 over 5, find cosine of A. Okay, so sort of similar. So let's draw a right triangle. Boom, 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 boom. So we got A, B, and C is the right angle. That's what it said in the problem. Okay, if SOHCAHTOA, write it down. Okay, so if the tangent of B is 12 over 5, so that would be the opposite over adjacent. So the opposite here is going to be 12. The adjacent here is going to be 5. So 12 over 5. Okay, so now what am I looking for? The cosine of A. So the cosine of A, here's A. Cosine is the adjacent over hypotenuse. So that's going to be the adjacent here, hypotenuse here. So I need my hypotenuse. How am I going to get that? Oh yeah, Pythagorean theorem. So this is the C, I guess you could say, in A squared plus B squared equals C squared. So you can do 12 squared plus the other leg squared, which is 5, equals your hypotenuse squared, because I'm looking for hypotenuse here. 12 squared is 144. Not equal, sorry. Plus 5 squared, 5 times 5 is 25. C squared. 144 plus 25 is 169. What's the next step? Oh yeah, square root both sides. And 13 equals C. Yeah, 13 equals C. So we have 13 right here. Boom. Now I can answer the question. Cosine of A. Cosine of A is the adjacent over hypotenuse. So that's going to be adjacent 12. So cosine of A equals 12 over hypotenuse. We just got it. 13. 12 over 13. Bam. Got it. Excuse me. Okay, so we got it. Let's do another one. Cosine of A is 8 out of 17. Tangent of A. Who knows? Okay. So, let's check it out. Picture. Boom, 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 boom. This is C. Let's call this A and B, like we have been doing. So, Katoa, write it in. Okay. Tangent of A, cosine of A is 8 over 17. So, cosine is the adjacent over hypotenuse. Go ahead and put this on your triangle. See if you do the same thing as I do. Go. Oh, yeah? You got it? So, this is 8 adjacent hypotenuse 17. Woo! Got it. Okay, so what are we doing now? We got to find the tangent of A. Tangent is the opposite over adjacent. So, we need the opposite side. We need this side. How are we going to get it? Yeah, Pythagorean theorem. Let's set it up. Leg squared plus, let's call this B, I don't know, whatever. Could call it A. Equals your hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. Cool. Okay. So we got 64 plus B squared equals 17 squared, which is 289. Woo! Okay. Subtract 64 from both sides. B squared equals 225. All right. Square root of both sides to undo the square. So we got B equals square root of 225 is 15. Oh, yeah. So we have 15 right here. Cool. All right. Tangent of A. Back to the business of solving the problem. So opposite is tangent of A. Opposite is here, 15. Adjacent is here, 8, and we done. There you go. Cool. Let's do one more. Oh, sorry. Let's do one more down here. Let's get rid of this. Boop. Let's move this up. Boop. All right. So if tangent of A equals 3, what? Usually it's got like over something. Oh, let's put it over 1. Because any number, can you put over 1, you get the same thing. Okay. So let's draw a picture. A, B, C. So, Katoa every time. Bam, like clockwork. So, tangent of A is the opposite over adjacent. And I put it over 1, so this is the opposite, and that's the adjacent. So that's going to be 3 over 1. Cool. Now, what is the cosine of B? That's my question right here. Cosine of B. So now I'm looking at B here. Cosine is the adjacent over hypotenuse. So what's the adjacent to B? Yeah, 3. This is the opposite. This is the adjacent. This is the hypotenuse. So I need the hypotenuse. How am I going to get it? Oh, yeah. Pythagorean theorem. Oh, yeah. Okay. So what are we going to do? So leg squared, 1 squared plus 3 squared equals hypotenuse squared. Call it C, whatever. 1 squared is 1. 3 squared is 9. And I have 1 plus 9 is 10. So square root is not a perfect square, so it's going to be radical 10, or square root of 10. What? Oh yeah, that can happen. So square root of 10 here. Cool. Now back to the question. What is the cosine of B? So that's going to be adjacent, adjacent over hypotenuse. So the cosine of B, adjacent to B, is 3. Hypotenuse is radical 10. Usually you can't leave a radical right there, but we're going to do that right now because that's what we're working on, just setting up the problem. We're not working on simplifying right now. So we got this. Ooh, ooh, ooh. All right, we got a lot of stuff. Now it's your chance to solve-y-solve. Do the best you can. Raise your hand if you have any question. Nice job today.